Hi, Elçin. Hope you're all fine. Well, let's quickly go for two extra exercises of the PAT test for Oxford Physics. Why am I doing two questions this time? Is because question number two is quite easy. You will see it's quite easy to work out. So what does it say? It says that a seed packet contains 100 seeds. And when planted, 70 of the 100 will successfully become plants. So that's like 75% of 100. But of these, only a third will have flowers. And of this third, only 1/5 will produce fruit. So the question is, how many seeds produce fruiting plants? Well, it's quite easy. So we start with, we have 75 out of 100 seeds that will become plants. Okay, so we did this and this. So here we have an amount. And of this amount, 1/3 will have flowers. So if we want to take 1/3 of 75 divided by 100, we simply multiply by 1/3. And then of this total amount, which we will calculate later, only 1/5 will produce fruit. So we take 1/5 means we're going to multiply by 1/5. So then we will have, if we multiply everything, we have 75 divided by 300 times 5, which is 1,500. And if we calculate this, we will find that it is 5. So this is very clear. This must be answer number A, the first answer A. Okay, so this was quite easy. Now we're going to exercise 3, which is a little bit more complicated. And so, well, remember, we're still doing all the exercises from the exam of 2023, which is the last exam online. Okay, so it says two black holes orbit each other. So that means there is a black hole, and then there is another one, which is orbit means it's going around in a circle. Okay, we know that already. And emit gravitational waves arising from the periodic nature of the orbit. So there are waves in between them. The orbital separation is around 10 kilometers, so meaning this is 10 kilometers, okay, between them. The relative speeds of the black holes are close to the speed of light. Now you have to know how much is the speed of light, and if you don't know, you have to write it in your notes, which is 300,000 kilometers per second. Now you have to know. And gravitational waves travel at the speed of light. So we know that the gravitational waves, they will travel at the speed of light. Important for our calculation. Which of the following would best describe the frequency of the emitted radiation? So we have a radiation which is emitted of this, the two holes orbiting. And so now we need the frequency, and then we will need the formula. That's also something you have to know, Elçin, that the frequency is 1 divided by t. Okay, that's a formula we will need. Okay, t, well, that will be the speed, and that will be, well, we will come to that later. Okay, so let's start. What do we have? We have the 10 kilometers. We have the relative speed of light. Okay, that's all we have. So the first thing we're going to calculate, and I hope I can put it all underneath here on this white space so that's very clear to you, Elçin. So the first thing we're going to calculate is the orbital period. And why is that? Because the orbital period, that's t, that's the period, okay? Period is t. And remember how you calculate t, and that you also have to know t is the distance divided by the speed. Now, the distance, that will be our circle. So this black hole is traveling like this. And the speed is the distance divided by speed. Okay? So all these, let me say information elements, you have to remember. This you have to know, frequency you have to know, and you have to know that when to calculate t, which is the period, you have to take the distance divided by speed. Okay, so now we're going to calculate t, which is, so the distance, well, this is calculating the circle, right? Circumference of the circle, which is 2πr radians, okay? Radius, sorry. Divided by, what did I say? The speed of light, 300,000 kilometers per second, okay? Okay, so we know that we have the 2, we know how much P is, and then R is, well, that's the 10 kilometers. That's R of my circle, right? Divided by 300,000 kilometers per second. And you see that we have kilometers here and kilometers there. So that's good because then we just have everything in seconds. And when you calculate that, you can do that with your calculator. And I found it's 2.1. Okay, 10 to the power of minus 4 seconds. Okay, so now we found t. Okay, that was the first step. Now we have the t, so really easy to calculate the frequency of the orbit. F orbit, let me write it like this, is, well, we know it's 1 divided by t, so it is 1 divided by what I just found here, 2.1 multiplied by 10 to the power of minus 4. Okay. And then, well, you know that the frequency is calculated in hertz, so our units will be hertz. If you calculate this, you will find more or less, let's do it like this, it's more or less 4,760 hertz. So if you have something else, please let me know, ELÇIN, then we will check where the difficulty is. Now, listen very carefully. If now you have to calculate the gravitational wave, the frequency of the gravitational wave, then really, I'm sure you know that, ELÇIN, but don't forget the wave pattern repeats every half orbit. So we have a circle here, and remember your wave pattern, and if you don't know that, you can also put it down in your notes, all the things you have to remember, is that the wave pattern repeats every half orbit. And so complete orbit is times 2. Okay, so what am I going to do? This times 2, times 2. Okay, and then I have the frequency of the gravitational wave, which is 2 times this, and this is going to be more or less 9,500 hertz. Okay, and let's see if there's one. Yes, it's approximately this one. So for me, the answer is B. I hope this is clear, ELÇIN. If you have questions, don't hesitate. And from time to time, I try to do an exercise of the exam. Have a very nice day. Bye.